capacity. Well, thank you all for being here. Welcome to the California Coastal Resilience Network webinar series. My name is Thomas Morales. I'm a 2025 Sea Grant Fellow working at the State Coastal Conservancy in the South Coast region. I'm the facilitator for the Coastal Resilience Network, as well as a project manager for the State Coastal Conservancy. And the California Coastal Resilience Network promotes knowledge exchange through webinars on climate-induced impacts on human communities and coastal habitats. If you'd like to join or watch past webinars, including today's on our website, I will include those links in the follow-up email. And let's get to it. So first up is the presentation, followed by a Q&A session. During the presentation, feel free to submit questions using the Q&A box. And the webinar is being recorded and will be available for review after the webinar. Recording now. Great. Today's presentation is about the REBEACH Oceanside approach to sustaining beaches, and the webinar will provide an overview of Oceanside's REBEACH pilot project, highlighting its innovative nature-mimicking approach to responsible sand retention and midterm shoreline resilience. And the presentation will discuss the project's design, implementation, pathway, and anticipated benefits, while emphasizing important elements such as monitoring, adaptiveness, community integration, and knowledge sharing across California's coastal communities. And our presenter today is Jamie Timberlake, who is the Coastal Zone Administrator for the City of Oceanside, where she leads programs in coastal habitat and beach restoration, resiliency planning, and coastal infrastructure protection. She manages the city's leading resiliency initiative, the REBEACH Oceanside project, launched as an international design competition to pilot innovative approaches for sustaining sandy beaches. With over 20 years of experience in both the public and private sectors, she holds a bachelor's in environmental science and geography from UC Santa Barbara and a master's in marine affairs and policy from University of Miami's Rosenstiel School of Marine and Atmospheric Science. And I'll pass the virtual microphone to Jamie to begin her presentation.
Awesome. Thanks, Thomas. Hope everyone can hear me. Sound good? And can everyone see my screen?
Yeah.
Yeah? Okay, awesome. All right, well, thanks for that introduction. Again, my name is Jamie Timberlake. I work for the City of Oceanside, and I'm here to give you an update on our REBEACH Oceanside pilot sand retention and sand nourishment projects, which is our main coastal resilience and sea level rise adaptation project, and with the big goal of lessening beach erosion and adapting our coastline for future sea levels. Thank you for the opportunity to present on this important pilot project, which is something that we're learning from. Hopefully, we're learning from it and being able to apply this to other circumstances along the coastline. And also, I'm just happy to be here because it's been a really busy 6 months, and we've made like some substantial progress on this project. So if you've been following along, you're going to hear some updates today that are brand new. But I'll start with a little bit of background. So Oceanside is centrally located on Southern California's coast. We're 35 miles north of San Diego and about 80 miles south of LA. And we're bordered by Camp Pendleton to the north and Carlsbad to the south. We have a population of 175,000 people. So we are the third largest city in San Diego County after San Diego and Chula Vista. The city covers 42 square miles and has over 3.75 miles of entirely city-owned beaches, which is pretty unique. Oceanside's southwest-facing coastline creates world-class waves, and we are the official USA surfing training site and home to major surf competitions throughout the spring, summer, and fall. And then we're also the hometown of Caitlin Simmers, our 2024 World Surfing Champion and Olympian. And then also Oceanside is a major transit hub. So we serve Amtrak's were served by Amtrak's Pacific Surfliner and Metrolink to LA and Orange County, and then the Coaster and Sprinter regional lines. But despite all those good things that Oceanside has to offer, our beaches suffer from chronic erosion, and since the construction of the Federal Boat Basin in 1942, which is on Camp Pendleton, just to the north of the city. So the boat basin was constructed in the Santa Margarita River estuary, which historically was the city's main source of natural beach sand. And the spoils from the boat basin and the harbor construction were all placed on Oceanside's coastline, which gave the appearance of wide, healthy beaches for many decades. But with our main sediment source being cut off almost entirely, the pace of erosion and the rate of natural or unnatural beach restoration has left us with chronically eroded coastline, as you can see in this aerial. So the city's REBEACH initiative stemmed from scientific and visual observation of beach loss, from the community encouragement to address this loss. This is like a truly community-driven project. And from policy initiatives guided by the Coastal Commission that aim to address vulnerable low-lying areas and future sea level rise. So in 2020, the city launched a feasibility study to identify immediate deficiencies in coastal management that we could readily address in the short term. And then the feasibility study was also helpful in determining a suite of possible long-term solutions to our beach erosion issue. That feasibility study concluded that a high-quality source of sand was needed to be identified and a nourishment program developed to provide more consistent sediment supply to the coast. But also that study identified that the nourishment program needed to be combined with a sand retention mechanism that could assist with retaining sand on the beach. Because Oceanside, though we know we're not the only city having a hard time retaining sand, we do have some unique factors at play. We have a totally straight and featureless coastline. There's no reefs, no pocket beaches, no coves, or really any topography that slows down sediment transport. So sand leaves our shoreline fairly rapidly after we place any on it. So in 2023, the City Council approved a contract to pursue the recommendations offered in the feasibility study, which was by and large to design, permit, and implement a pilot sand retention system coupled with beach nourishment. The city desired to use a different type of retention than is traditionally used. So to find a new sand retention tool, the city held an international design competition in this beginning in the summer of 2023, which gave us the opportunity to kind of see what other sand retention solutions were out there being tested in the world in areas where they were already dealing with similar coastal stressors. So the 8-month-long final design competition hosted 3 competitive teams. They came from New York City, from the Netherlands, and from Australia. And these are just some of the images from that design competition, some of the solutions brought forward by these teams. The final competitors were given the initial design parameters for the competition, which were directly in alignment with the feasibility study recommendations. And so all the competitors were asked to design a sand retention feature that would restore and maintain sand along the coast while increasing the efficiency of any and all sand nourishment efforts that the city, region, or federal government carry forward. So of these 3 designs that were brought forward, the winning concept design that Oceanside is now planning for its shoreline is ICM's Living Speed Bumps design, which mimics an innovative implemented reef system on the Gold Coast of Australia that just recently went through a cyclone. Throughout the design competition, each design round culminated with a presentation to the public at a public workshop, and they were all very well attended workshops. The public comments gathered at the workshops informed the designs of each of the design competitors, and throughout the whole competition, so that the public was directly involved and very, very much keeping up with the effort. And all that information that we gathered at these public workshops, it continues to inform and guide the project design. Aside from public workshops, we've also been doing a fair bit of regional stakeholder outreach. And you can see a few of the touch points that we've had with the region on this timeline. We have been working closely with SANDAG, the San Diego Association of Governments, since the initiation of REBEACH, which has given us not only an opportunity to provide regional outreach, but also because understanding and testing of sediment retention or sediment management devices in San Diego region has long been something that SANDAG has sought. They've been including us in a lot of their discussions, and we've been part of their policy document updates. And so just recently in June, SANDAG's Shoreline Preservation Working Group officially adopted our pilot project as the regional pilot project. And SANDAG is expected to support the city through environmental compliance and hopefully through finding fundraising and finding some funds to construct our project. So onto the fun stuff, the project itself. So this is a visualization of the refined living speed bumps project design, which we now just call the REBEACH project. And this is the design in the selected pilot project location. So the pilot project design includes all 4 of these elements that are listed here. The bidirectional wave energy dissipating artificial reef is that game controller shape in this image. It's expected to be situated between the 2 headlands and at depths of 15 to 22 feet. Again, this is an area with no offshore natural reef structure, so the reef will be constructed on the sandy seafloor. The headlands on either side of the reef extend off of the Strand, which is our coastal frontage road, and these will help retain sand on the back beach. The onshore and nearshore sand nourishment element adds sediment into the littoral cell. Since we have been cut off from a majority of our natural sand supply, we need to grab that sand and add it back into the system to maintain any semblance of a beach. And then finally, an important project element is that we have an approved local sand nourishment borrow site. And that's down in the bottom in the green. We were strategic in planning for the coring and the geologic surveys to locate an offshore sand borrow site, but we were super lucky to have found suitable sand just west of the project area, and a majority of this local borrow site is actually within our granted trusted tidelands. So also pretty lucky on that find. So since this is a pilot project, we wanted to select the most suitable location for testing our system. The project team analyzed various layouts for the headlands and reef in each of these 3 shoreline segments south of the pier, where most of our erosion persists. A multi-criteria analysis decision matrix was used in assessing the siting, allowing the project team to evaluate comparable metrics in each of these locations. And then ultimately, public input and the results of the criteria analysis led the City Council to unanimously agree to site the pilot project in segment 1, which is south of the pier and along the public frontage road called the Strand. So just like this pilot project can yield lessons for the region, we also expect to utilize the information and best management practices gathered from this effort to potentially implement iterations of this design in other areas of Oceanside's coast, like in segment 2 and 3. Currently, we are in final design and engineering for the project, which includes advanced modeling and design specifications, The design and specifications are being aided by 2 solid years of consistent, substantial baseline monitoring. Baseline monitoring includes tracking currents, beach width and volume, cataloging surfing and surf resources, and establishing biological conditions ahead of the implementation of the project. We're doing continual outreach, like today, to the local community and to jurisdictions in the region. And with all of the project and community development, we are now also beginning environmental compliance. I shouldn't say beginning it. We've been doing a fair bit of early engagement with a lot of the agencies. So early in the design competition, we actually invited the Coastal Commission and a few other agencies to participate in the project development. So coordinating as early as possible to assist with designing from the beginning for regulatory compliance. And then lastly, we're working out construction and adaptive management funding strategies. So for construction, we're likely to seek out state and federal and regional grants. And then for continual funding for coastal management, we're investigating how the city can leverage funds coming from sales or property tax, as well as transient occupancy tax. So if you've been following the project for a while, all the things I've been discussing is probably not too new, but from here on, I'll be kind of like revealing the latest developments. This is going to be the first time we've been talking about the modeling results and the design of the artificial reef. So these are the 4 modeling approaches that the project team has been busy with this past 6 months, trying to simulate wave and sediment transport processes, with the goal being a project that buffers wave energy and retains sand, but needing to also minimize downdrift impacts, minimize marine safety concerns, and then limited effects on any surfing. So empirical analysis was done early on in the modeling phase of the project and somewhat in the phase 1 of the project. The analysis gave us the overall goal of developing a reef that encourages currents that thwart the most erosive wave conditions and then help shoal sediment in the nearshore environment. So with that goal in mind, the project team then developed and ran various reef shapes through the hydrodynamic model. And that gave us a deeper understanding of how the waves in various swell conditions and water levels break on various reef shapes. And then how those broken waves influence currents. So that's kind of the results of the hydrodynamic model have led us to understand how these different reef shapes interact with our swell conditions. Now that the hydrodynamic modeling is complete, we have a selected reef shape, or what's called a parent reef, and we're going to be adding sand and existing conditions of the shoreline into that overall assessment using that parent reef, and then analyzing that through a different type of model called a morphological model, and that model is called Mike 21 for those of you modelers out there. We also have a unique opportunity coming up in February to study the wave breaking conditions of a scaled version of the reef in a physical model or a wave tank. And this will help calibrate all the numerical modeling that we've done, and then it will refine the specifications of the final project design. So these are the 4 basic reef shapes that were assessed in the hydrodynamic model. Over 40 iterations of these basic shapes were assessed. We put the iterations of these shapes through 2 different water levels and 5 wave conditions from the northwest and the southwest. And this led to over 800 plus simulations. The hydrodynamic modeling led us to these key performance indicators that we use to compare one reef iteration to the next. And then the outputs from the modeling gave us an understanding of how much the reef would provide wave energy dissipation, which is that main erosive force on the shoreline. But again, we want a reef that buffers wave energy and retains sand while minimizing impacts to downdrift beaches and all the surf amenities in Oceanside. So from all those tests, we've selected this parent reef design, which accounts for waves coming from both the north and south, since our coastline is exposed to all swell directions. This parent reef is what we'll now move forward with through the morphological and the physical modeling phases. As we move this shape into these models, we're expecting to tweak various dimensions of the parent reef, like the bridge crest height or the length of the arms. As it's currently designed, this reef is fairly prominent with a width of 600 feet and a length of over 900 feet length along the coastline. And then the crest could be viewable at some tides as it's currently designed, but these are all subject to change slightly from the next two modeling phases of the project. And then from that morphological model, we'll also be refining other project elements like the depth of the reef, the amount of sand needed for initial nourishment, and the seaward extent of the headlands and the rocky outcrop. So moving on to the headlands and the shoreline side of the pilot project, these are the existing beach conditions at each of the headland sites. This is Tyson Street Park on the left, and on the right is Wisconsin Avenue. So yeah, this is the current status of our beaches in these areas. We are currently discussing the headlands and the configuration of amenities, both publicly and internally at the city. We are trying to design the headlands to provide additional user benefits to these areas, maybe making up for something that is not currently present in these public spaces. And then also we're trying to predict how the headlands can facilitate and enable the expected increased beach use that we want to have after the project is implemented. It's been really challenging to project this to folks, especially at the city, and how the public interaction in these areas is going to change after the project is implemented, since we've had no sand for so long. And as you can imagine, there's not much beach use going on any longer, especially at the Wisconsin location. But this area used to sustain dry sand beaches, and in fact, it was the high school surf team drop-off location. So lots of surfing happening off of Wisconsin in the past, and that's no longer the case. So in the design of these new spaces, we're hoping we can capture how the public use will change in these areas, and we're hoping to implement that in the design. This past summer, we held a public meeting about the desired amenities to be featured on the headlands, and pretty much the community voiced that there is strong preference to keep both headlands with a passive design, meaning minimal programming. Folks really just want a place to view the ocean and pull over and pause while walking, riding, or running on the strand. And then there's this strong desire to improve the ease of access to the ocean. But just sustaining sand at grade with the strand, which is a project objective, I mean, this will hugely improve access. But we're also looking to add a Moby mat and maintain a sand ramp for the lifeguards. There's been a lot of input from not only the public, but from internal teams at the city. So marine safety, Oceanside Police Department, Public Works, Transportation, CIP Engineering, Parks and Rec, and Water Utilities. They've all been involved in the development of the headlands design. And this draft design of the Tyson Street headland incorporates, a number of other things that the city team has provided input on. So like a lifeguard tower, the need for more bike and surf racks, some seating, and then also possibly some education about surf safety, or maybe some opportunities for public art. Aside from the amenities on the headlands, the headlands are also functional sand retention systems, which will further be designed through the morphological modeling phase. The headland park space is expected to extend off the strand about 150 feet, and we don't expect that dimension to change significantly, but we do see opportunity for refinement in the rocky outcrop element, which extends off the headland and will likely be buried by sand for a majority of the year. That rocky outcrop is one element that we see as highly adaptable. For instance, if we're not meeting sand retention objectives, we may need to augment the outcrop, or we may be so successful with sand retention that we can pull back or remove portions of the rocky outcrop. But the idea is to have that be the adaptive element and then maintain the designed park space on the headland so that we don't have to adapt that too much. So monitoring to establish the baseline conditions ahead of this experiment is a huge part of the REBEACH effort. Baseline monitoring includes tracking the currents with acoustic Dopplers that have been deployed for 6 months now, I think. And we're also tracking the wave conditions. We are studying the beach width and volume along established transects that you can see here. We are conducting bathymetric surveys to thoroughly understand how natural sandbars are developing, and how that, so that we can understand how we're going to change that development in the future. We're also cataloging surf resources using Surfline's Coastal Intelligence new set of tools. And then we're establishing baseline biological conditions ahead of the implementation of the project. Because this is a pilot project, the baseline monitoring program is pretty robust. Since this monitoring will develop the conditions, that will compare against once all of the elements of the project are implemented. So we have been actively monitoring since 1997 with the help of SANDAG and their shoreline preservation working group and the monitoring program that they helped establish in San Diego County. But with a grant from the Coastal Commission, we've been able to augment this program to be more comprehensive. So this baseline monitoring work further roots this project in science, since we'll be able to really hone in on what's worked for this pilot effort and what didn't with this extensive data set. The baseline conditions are also a huge part of the adaptive management plan, which is also very important to develop when working under the context of this kind of new coastal management tool. The project is anticipated to require maintenance and may need to be adapted over time as maybe damage occurs or performance decreases as sea levels rise. So an adaptive management plan is in its infancy. It's being developed now based on baseline conditions. And it will identify triggers and actions for managing the project over the short, mid, and long-term planning horizons. So an example of that is like once the project is implemented, if we start to see a change in beach width compared to the baseline condition, we can adapt to the change by accessing that local sand supply source, that local borrow site, and then adding that sand to the affected area. It's just one example of how we can adaptively manage the project. It's anticipated that these types of triggers to action will be developed in this adaptive management plan, and then the expectation is that this will be overseen and approved by the permitting agencies. So with the development of a coastal adaptation project of this magnitude, there's been some considerations and challenges that we're currently working through, and I wanted to just highlight a couple of those that work that's being done right now. So firstly, like coastal management and the implementation of coastal adaptation projects, these are not traditional CIP engineering projects. So especially when it comes to beaches being considered like infrastructure, there's a huge misconception by the general public that beaches will always be there no matter what's done up coast or up in the watershed. And so the management of beaches and the funding for these efforts, there's not a lot of public community driving this at the city level. And so, except in Oceanside, we've had some unique, very active stakeholders, but this is not something that is entirely integrated into existing local government structure. Sometimes I think that we are almost at an advantage because we've had such chronic erosion. It's really evident that that there's a problem, and so the community has been able to wrap their heads around it. But it's a really an interesting time right now to be working through these issues at the local government level. So we're still working through a lot of funding challenges for REBEACH. We're completely funded through the design and permitting until we are shovel ready. But in general, we have coastal management needs to be funded at the city level, and we're working through those issues. Whereas where a traditional CIP project may be funded by development impact fees or something similar, the funding for the maintenance of beaches is traditionally standard. And especially, I would say this is challenging if your city doesn't have a staff person to advocate for this need. That would be an even bigger challenge for implementing an adaptation project like REBEACH. But fortunately for Oceanside, the city is investing in the creation of a coastal management position and and integrating the needs for adapting the coastline into local government. This is something I'm working through right now. For our pilot project, we are hoping to get construction funding through state, federal, and regional grants. For adaptive management and continual funding for coastal management, one of our partners for REBEACH recently completed an economic analysis and feasibility assessment on how the city can leverage funds like additional sales tax or property tax augments, or increasing or reusing transient occupancy tax, which could fund continual coastal management and REBEACH maintenance needs. And though these funding sources are kind of identified and we are aware that they exist, they are politically charged. So it is we are working through that continual funding element for this project. There are, of course, regulatory hurdles around this project, being the first of its kind. But early on in the design competition, we invited participation from the agencies to weigh in on our design, and we keep in contact with these agency representatives through advisory groups that we've formed. We have 3 advisory groups, one that is focused on modeling, one that's focused on surf resource preservation, and then another that's focused on biological conditions and assessing those conditions. So the hope is that the guidance from these regulatory agencies that have been involved for so long, that we've been listening and designing a project that fits into the agency policy guidelines. We have a sand source for maintenance, which is our local borrow site. We've had that material approved by the overseeing agencies. But we recognize that sand is a limited resource, and that's one thing that is really important to recognize in this project, because we are trying to retain some of that sand, so retain some of that effort and not keep having to go back to a limited borrow site. And then finally, one of the consistent challenges we're all working on is that there's uncertainties with sea level rise. So we expect to address these uncertainties through our adaptive management planning, but several elements like sustaining that local borrow sand source and using that for maintenance, we need to have those all work together so that we can effectively adapt the project. So again, fortunately for me and for this project, the city of Oceanside is making huge investments in building coastal management capacity, and the coastal management division is now a team of 2.5. So hopefully these hurdles that we'll be able to get through this with a little more dedication and some human resources. And with that, I'm happy to answer any questions. And we also have our GHD project manager, Nick Sajapur, here with us. So if you have any technical questions, I'm sure he'd be happy to hop on.
Thank you, Jamie, for the presentation. This is a very exciting project with many potential benefits. And yeah, as questions appear in the chat, I will read them, and I will, yeah. Megan, you can ask your question.
There we go. Here. Hi, Jamie. Thank you. Thank you so much, first of all. That was really interesting, and really appreciate you doing the webinar. I have 4 questions, but I know other questions are rolling in, so I'll only ask a couple and then let other people go. So the crest of the reef at its highest point, it said 5 feet, and I wasn't sure, is that +5 mean lower low, or what's the height of that?
Yeah, I'm happy to jump in. Right now in the modeling and in that design, our reef is essentially split into these 2 features. One would be that bridge, that centerpiece, and then on the sides of it are those 2 arms that are kind of cross shore, west to east. And the bridge crest is in the modeling right now is 5 feet mean +5 mean low water. But we're going to be testing other crest heights in our physical model to understand the trade-offs with lowering crest or higher crest, and what are those performance characteristics from that. I think the challenge for us in balancing, how emergent it is over time is thinking not only about settlement. So as you place this reef, how much might it settle over time just from being a new feature out there in the ocean, but then also thinking about sea level rise of what do we want to plan for in this initial design and construction for having it persist and perform over time. The crest of the arms is much lower. So you can see there in the upper left, the seaward crest of that arm is -2 mean low water, so pretty submergent. And then you have that 0 at mean low water. So it would be emergent sometimes, but pretty infrequently. Extreme low tides.
I'm curious if you know, about how often a +5 mean low water is.
It's almost like
emergent.
I've imagined you asking that question. You can either you can either do it by daylight hours or by just rough tide gauge. I can follow up with you on that. It's essentially kind of just like a curve that the higher the crest elevation, the more emergent over time, the lower the less emergent. But yeah, I can follow up with you, Megan, on that.
Well, that's okay. I was just curious. I mean, this is all actually just one question. Third part of my first question, and then I'll stop. I'm curious if that's a question that the regulatory agencies ask you and are worried about if it will be seen or not seen.
That hasn't, I mean, aesthetics and visuals are pieces that obviously are concerns. I think more of what we've heard is about monitoring and adaptive management and thinking about the performance of, directly behind around the project, but then also adjacent north, south, what are those cascading effects of purposely reducing sediment transport. Obviously we're talking about adding a significant amount of sand supply, through beach nourishment. And this project is hoping to improve the performance of that beach nourishment. The past large scale beach nourishments that have happened in Oceanside have only provided, a year, 2, 3 max benefits. And the idea is how we can get better return on that investment and then actually, have some management tools for the city and Jamie and keeping that sand around a little bit longer while not having significant impacts down coast or up coast.
Thank you.
Great. Well, thank you for those questions, Megan. It looks like Evan had a question. I've allowed you to unmute if you'd like to ask your question.
Thank you, Thomas. Hi, Jamie. Hi, Nick. I'm sorry if I missed this, but I was just hoping to learn more about the headlands. Like I could imagine trying to size those to actually have some sand retention benefits could be really challenging. Like natural headlands are very big. So can you speak to that design in a little bit more detail, like the sizing and how you determine that? But then also, what will they be made out of? Like, I'm just guessing there's going to be like excavation and there's going to be rock and then there's going to be dirt and then maybe some concrete. Or I just would love to know more about the materials.
Yeah, I'm happy to kind of walk you through. So again, all of this design came from the design competition. You know, that was the design, the origination of these major elements, the headlands and the reef. For the headlands, these are these more minor features that have been tried by International Coastal Management in Australia, and then they looked at local systems. So in particular, the base of the pier is like a rough analogous size. The base of Oceanside Pier, to be clear, which is just left of the screen, a little bit north. So as you can see in this diagram, that width of that, top semicircle piece of the headland is about 150 feet wide. That's really to try to provide some benefits for visitor amenities and some multi-purpose aspects to the sand retention piece of this retention feature, retaining sand on that backshore. That controlling rocky outcrop that protrudes out towards the ocean is really where we're going to see a lot of those benefits from stabilizing sand on that backshore and slowing down that sediment transport along shore. And that's something that we'll be refining through the morphological model. So kind of testing, that crest height of that rocky outcrop and then how far offshore it goes. In terms of what it's made of, it likely will be made of quarry rock. In terms of the foundation kind of around the crest of that and then that rocky outcrop, we're looking at less not concrete on top of it, trying to use sand as much as we can or pavers, something that's more temporary given that it's a pilot project and to provide some flexibility to some of the programming on top of it. And that'll be a new feature, a new place and space for the city of Oceanside. And so thinking about in particular lifeguards, safety, and then OPD, Oceanside Police Department. We've had a lot of conversations with them about, we can all imagine how the operations might go with these new spaces, places, and uses, but that it would be beneficial to build in some flexibility if, as people use this, as lifeguards respond, there might need to, tweak the location of a lifeguard tower, let's say. Like maybe it doesn't make sense to have it right on the end there. Maybe it's actually better on the sides or closer to the strand. We're hoping that we can build some of that flexibility and adaptive capacity, if you will, into kind of what's on top of them.
Thank you.
Awesome. It looks like,
yeah.
We have a comment from Caitlin or another question. Is the potential vehicular access just for emergency vehicles?
Yes, it would just be like lifeguards, OPD, or maintenance.
Awesome. Looks like we have a hand raised from Megan.
And let others go if there's other questions. Doesn't. I'll jump in again just to sort of pick up on the headlands question, follow up on it. Right now the design looks circular. Is that something that will be sort of further looked at, or does it need to be sort of a circular shape? Or I don't know, I kind of picture a headland kind of going out into a point, or is that more of a functional shape for retaining the sand?
I guess I'll answer it in two ways. So, we're largely looking at this semicircular shape to provide sort of the as much square footage on top of it for recreational amenities and multi-purpose. Again, the kind of controlling sand retention feature is going to be that length shore perpendicular of the rocky outcrop that's slowing down the alongshore transport of sand. And, the best reference site is in Salt Creek. It is kind of more triangular in shape, But for what we've worked with at the community and talking with kind of the local city departments, this sort of design and shape has been one that we've gotten a lot of positive feedback from.
Yeah, it's also mimicked after the Townsville headlands in Australia, which are circular. And from ICM's initial project design, the idea was that because of that circularity, there would be a little bit less likely to retain the sand too much, that the sand could move around the end of the headland a little bit better. So rather than like trapping it in one spot like a pocket beach. But the headlands is something that we're designing in the future more. This is something that we kind of have just retained the same design dimensions from the design competition, but it's going to be included in the rest of the modeling approaches.
Thank you.
So it looks like we have 2 more questions in the chat. One from Karen. Is the rocky outcrop envisioned to provide some rocky intertidal habitat? And Evan also asked if there was going to be any habitat benefits as part of the design of the big artificial reef. And that's something I'm interested in and seeing what species may utilize the reef. So
Yeah, and we had a meeting with our ecology advisory group and had a long discussion about this in terms of kind of the overarching goals for the project. It's the sand retention, trying to bring back this beach to Oceanside, and thinking through, what are those goals that we should set in terms of ecological features. And really where we're prioritizing is getting that beach back, as Jamie is showing on these slides. Like, there is not a lot of that viable beach habitat for grunion, invertebrates, shorebirds, and the like. And so by retaining sand and bringing back that ecosystem to Oceanside, that's really where our ecological focus is. That said, as someone who grew up diving breakwaters and jetties, like you put something out in the ocean, critters are going to be attracted to it. They may also serve as something that could grow organisms and different species. We'll certainly will be monitoring that, but in looking at a lot of the different proprietary constructions and materials, those costs, and how those potential like reef ecological goals versus the sand retention goals. There's only so many things we wanted to pilot in this project, and so we felt confident in sort of focusing on the sand retention piece, but monitoring the reef and the reef ecological aspects. And to I think it was Karen's point, it's going to be intertidal at those higher crests, but then it will go all the way to subtidal, and then same thing for the headlands. In response to how that sand stays. Part of that rocky outcrop might just be fully inundated by sand. In the best case scenario, we're doing a good job of retaining that nourishment. But if we do have maybe seasonal changes in beach width and sand volume onshore, maybe tips of those headlands do serve as some habitat, similar to, the various, the 6 jetties in Carlsbad that protrude from kind of that back beach where they're covered in sand, and then they go into the intertidal, and the lobsters, urchin, fish, algae.
You're revealing all of your secrets, Nick.
I didn't name any spots.
I'll just add that when we do the harbor dredging and we place sand on the beach as a bypass measure, we immediately have grunion because the harbor dredging happens every spring. It's happening during grunion season, and so we monitor for it. We have 0 grunion in the areas like seen here on like at Tyson Street. Definitely at Wisconsin Avenue, there's nothing for the grunion to land on. But as soon as we place any sand, the grunion are there. So it is providing habitat by having a sandy beach, or we have none. Yeah.
But we will be monitoring biological monitoring of the reef, so that hopefully this pilot project could provide insight into maybe future reefs. I know CDFW is kind of working through the California Artificial Reef Plan, which is largely focused on the ecosystem benefits. And there's a long history of artificial reefs for, ecological mitigation. And so we're hopeful that our project could kind of serve as a reference point and data source for informing future projects like that.
Thank you for these thoughtful questions and insightful answers. Are there any other questions at this time? Holding that education pause, but well, thank you all for your time, and thank you, Jamie, for presenting this very exciting project, and look forward to visiting this one day and maybe catching a few waves outside of the reef. So thank you all for your time.
Awesome. Thank you. Appreciate it.
Thanks, Thomas.
Okay.
Good to see you, Evan. Thanks all.